In this video, I'm going to go through the patterns and systems to fill in the trig chart, focusing especially on the radians, sine, cosine, and tangent columns. Usually you are given the degree column, although you should be able to fill that in yourself as well, as long as you know the patterns to start from 0 and add 30, 15, 15, 30, 30, 15, 15, 30, 30, etc. So remember, if there's ever a radian measurement that you're nervous about and you're afraid you don't remember it, you can use the conversion fact to take the number of degrees you have and multiply by pi over 180. If you reduce that fraction, that will also give you the radian measurement, especially if you just want to check one maybe halfway through and make sure your numbers didn't get off system. So I like to start off with the 45-degree angle ones. So starting here from 0 degrees, I'm going to fill in 0 radians. And then if you go to the next 45-degree increment, I'm just going to keep adding 45 degrees at a time to go from one to the next. So this value would be the 1 pi over 4 number. And then going to the next increment of 45 degrees, that would be 2 pi over 4, but make sure you reduce those fractions. Adding 45 again takes you to this value, so that gives you 3 pi over 4. And then adding 45 degrees again here is 4 pi over 4, which we reduced to just be pi. So continue this pattern. We're just going 1, 2, 3, 4, 5 pi over 4. Six pi over 4. Seven pi over 4. And then 8 pi over 4. This is another name for the 0 degrees value, but for completeness sake, we like to fill this one in as well. So 0 radians is the same as 2 pi radians. It's just spun around one complete time. So you can see that this is actually just every other number on the table, which is another way to help you remember which values you're filling in. Or if you're paying attention to the degree numbers the way I was, you're just adding 45 at a time to go from one number to the next. So start from 0 pi over 4 and add 1 pi over 4 for each value. 1, 2, 3, 4, 5, etc. Next, we're going to use a similar system for the 30 degree measurements. So this one's going to start at 1 pi over 6. And then this pattern is going to happen every 30 degree mark on the chart. Unfortunately, it will not be as easy to keep track of it being every other number, because we have to keep track of the fact that we're going from 30 to 60 and then from 60 to 90. Now we already filled that number in, but we still have to count it when I'm going through and listing 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, etc. So now for the ones that increase 30 degrees at a time, increase your radian measurements by pi over 6. So this is 1 over 6. This will be 2 over 6, which you need to reduce. The next one is 3 pi over 6. We already have that filled in. And then 4 pi over 6 also gets reduced. Here's 5 pi over 6. Six pi over 6, which is already filled in and reduced, onto 7 pi over 6. So again, the reason I know which ones to count on this is because I'm going by 30 degrees at a time. So it might be helpful to even make a mark on the degree measurements as you go down. You're hitting the 30, 60, 90, 120, 150, 180, 210, 240, 270. So just keep adding 30 degrees at a time, and those will be the ones you need to add this pattern to. So 7 pi over 6, add pi over 6 again, that's 8 over 6, which reduces. Nine over 6 we already have filled in. 10 over 6. And the last one we need is the 11 pi over 6. So that takes care of all of the radian measurements filled in on the chart. Next, there are 5 numbers you need to know for the sine and cosine columns. And the numbers correspond to the coordinates we learned for the unit circle. So sine starts from 0 and it increases. So it goes to the next number of 1/2, and then square root of 2 over 2, square root of 3 over 2, and then 1. Those exact same 5 numbers used in the sine column are the numbers used in the cosine column as well. We're just flipping them upside down. So instead of starting from 0 and counting up to 1, we're going to start from 1 and count down to 0. So I like to fill in the cosine column right now while I'm at it too. So this one's going to count down, 1, square root of 3 over 2, square root of 2 over 2, 1/2, and 0. So we talked in class about how there are certain values that are kind of like mirrors around the trig chart. So 90 degrees is one of those so-called mirrors. Once you hit this value of 1, the graph is just going to reflect around that. So the closest thing to our mirror is the square root of 3 over 2 value. So I'm just taking the numbers above 1 and I'm duplicating them back down below, but it's going to flip the order. So now instead of going from 0 up to 1, basically it's going to go from 1 and then count back down the same way we did with the cosine column. So square root of 3 over 2 and then square root of 2 over 2, 1/2, and 0. And then it's going to repeat that pattern. So this is going to happen at every one of the 90 degree marks. So now that I've added another 90 degrees, I hit 180. This is another one of my mirror values. So now it's going to go right back to counting up from 0. So 1/2 again, square root of 2 over 2, square root of 3 over 2, and 1. And then that's another one of our 90 degree increment marks. So now it counts back down from 1 to 0 again. So we're using those same 5 values over and over and over again. So it's not many numbers you need to memorize. And like I said, you really only need to know the first 5 values and you can fill in the rest of this chart. We can do the same thing with the cosine numbers. This one started from 1 and it counted down, and then it's just going to keep bouncing back and forth. So now instead of going from 1 to 0, it's going to go from 0 back to 1. It's going to count back up. Again, if you're thinking of this as a mirror, the closest thing to the mirror is the 1/2. The next closest is the square root of 2 over 2. And then keep counting up. So the next one's square root of 3 over 2. 1. This is our next flipping vector. So now the numbers count back down. And we do have to fill in the signs, but I'm waiting till I get all the numbers filled in before I go into the positives and negatives. So right now I'm just paying attention to the numbers themselves, ignoring plus and minus. And then one more time we flip it, now it's going back up. So whenever you hit 0, count up. Whenever you hit 1, count down. For the tangent column, technically you can get these values by saying y divided by x. Remember, sine is the y values, cosine is the x values. So 0 divided by 1, for example, is 0. And then you can do 1/2 divided by square root of 3 over 2, and square root of 2 over 2 divided by square root of 2 over 2. Any number divided by itself is 1. But honestly, I would just recommend memorizing the first 5 numbers of the tangent column, just like I recommend memorizing the first 5 numbers of the sine column. So the numbers you want to know for tangent are 0, square root of 3 over 3, 1, square root of 3, and undefined. And again, you can get each of those values if you want to double check by picking the sine number and dividing by the cosine number. So for example, 1 divided by 0, you can't divide by 0. That's what creates an undefined value. To actually do those computations, you might want to think of it as keep, change, flip. Don't divide by a fraction, multiply by the reciprocal. So if you're multiplying square root of 3 over 2 by 2 over 1, the 2's cancel. That's why the answer is just square root of 3. Now the tangent column follows the exact same pattern that the other ones do. So now that I've hit this value at 90 degrees, it's just going to flip around again. So the one closest to the undefined value is square root of 3. The next one is 1. And then square root of 3 over 3. And 0. And that's another one of my values. So now it just bounces and it does it again, this time counting back in this direction. So square root of 3 over 3. And then 1, square root of 3, and undefined. And then one more time, we hit our next 90 degree measurement mark, the 270, So it bounces again, square root of 3, 1, square root of 3 over 3, and 0. So the last thing we have to do is actually fill in where are the graphs positive and negative. And it may help you to picture the unit circle for this, because what you want to remember is that sine is based on the y values, cosine is based on the x values, and tangent is based on y over x. So if you're thinking about your unit circle, we have the 0 degree mark on the right, we have 90 at the top, 180 on the side, and 270 on the bottom. So if I say sine is based on the y value, that's going to be positive until you hit 180 degrees. And then once you go past 180, you're going to have a negative y value because it's going below the x-axis. So in the sine column, I just come down below the 180 mark and I make all of these negative. These are the ones that would have negative y values because they go below the x-axis. Once you hit 360 again though, 360 is just going back around to this value, so it's actually a y coordinate of 0, which means it's neither positive nor negative. So there's no such thing as a negative 0 on that very last value in the sine column. Cosine is going to be a similar system, but now it's based on the x coordinate. So the x coordinate will be positive whenever you're going to the right, which is going to be up until you hit 90 degrees, and then it'll be negative all the way until you hit 270. So I'm going to take all the cosine values between 90 and 270 to make them negative. And then this one's 0, so again, it doesn't make sense to have a negative 0, so that's where it flips back. For the tangent values, since that's based on y over x, it will be positive when both x and y are positive, which is the first quadrant, or when they're both negative, because the negatives cancel out. So I need to put negatives in between 90 and 180, and then again between 270 and 360. So between 90 and 180, and then again between 270 and 360, but not including the values in between. So that's all for filling in the trig chart. Thank you.